Hey guys, and welcome back. Today we're going to cover a few more questions off the Math ACT. Now remember, the best way you can prepare for this test is to just practice. So let's dive in and do just that.
All right, so for number 6, we actually have to plug these two numbers into this equation. Now, typically I'll do this in my head, but let's go ahead and get everything written down so that you can see what's happening here. So this is our square root symbol, and for m, we are placing in the number negative 16. Then underneath that, we have x, which they said is going to be negative 1, and then minus 3. Now, negative 1 minus the 3 is going to give me negative 4 down there on the bottom, but we still have that negative 16 on the top. Well, a negative divided by a negative is going to give you a positive, so those will cancel out, and 16 divided by 4 is going to give me 4. So we are going to end up with the square root of 4. With that said, we need to go ahead and actually take that square root. So when we take the square root of 4, that's going to give us 2 as a final answer. So we're looking at option G. Now, if you're wondering where these other options are going to come in, of the square root 2 or the i's, that's because if you have a number underneath the square root that is not like a perfect square that can be square rooted easily, usually they'll just leave that in the answer. So if I ended up with like a square root 3 underneath, you can't take the square root of 3 easily, so they actually leave that radical in the answer. And the I, remember, is if you end up with a negative underneath that square root. So if I see something like the square root of negative 1, then that means that I'm going to end up having an I in the answer. Or in this case, we did have negatives here, but if we ended up with a square root of negative 4, we would have had a final answer of 2i and not just 2. But because our negatives canceled out, we didn't have to worry about any of that here. Okay, so for number 7, it says tickets for a community theater production cost $6 each when bought in advance, $8 each when bought at the door. The theater's group goal is at least $2,000 in ticket sales for opening night. The theater sold 142 opening night tickets in advance. What is the minimum number they need to sell at the door on opening night to make their goal? So it's essentially a formula with two variables here where they gave us one. The first is 6 times the number of tickets they sold in advance for $6 for each one, plus 8 times the number that they sell at the door. And they need that to be at least $2,000. Now, I put equal sign here just so we know what it is we're solving for, but in reality, they just need to be larger than or equal to this. So first off, they do tell us that the X is 142, because they tell us that's how many were sold in advance, and we can go ahead and multiply 6 times that 142 to find that we get $852 have already been made. Plus the 8 times our door prices equals that 2,000. From here, we just need to solve for y, so we're going to subtract the 852 from both sides. And that's going to give us that 8y is equal to 1,148. Then we need to divide both sides by that 8 to get a final answer that y is equal to 143.5. So in this case, that's not going to be one of our answers, but we need to know how many tickets we need to make at least 2,000. So that means that this would put us at 2,000 even, which means we need to be higher than that, otherwise we won't have enough. So what's the first number of tickets that would be higher than this? 144, which means our answer is B. Now remember, I'm not doing all these calculations in my head right off the bat. That would be a waste of your time. You should be using a calculator to knock these out. Hope that's helpful. Thanks. So number 8 here says that Mark and Juanita own a sandwich shop. They offer 3 kinds of bread, 5 kinds of meat, and 3 kinds of cheese. Each type of sandwich has a combination of exactly 3 ingredients: 1 bread, 1 meat, 1 cheese. How many types of sandwiches are possible? So this is actually something that falls under statistics. And the ACT has been hitting a lot harder on statistics over the years, but this one in particular, although it talks about combinations, is not a combination permutation question. It falls under the fundamental counting principle. So what does the fundamental counting principle say? Well, the fundamental counting principle says that if you have multiple options for several things, and you're only allowed to use one from each thing, then you can actually just multiply the number of options for each category together, and that will give you the total number of options that will work. So in this case, we have 3 kinds of bread, we have 5 kinds of meat, and we have 3 kinds of cheese. So we just have to do 3 times 5, which is going to give us 15, times another 3, which is going to give us 45 to get a final answer here, which is option J. So number 9 here is a straight up just computational algebra question where you're solving for x. Now there are two major ways to handle this. You could go ahead and divide both sides by the 12 first and then add the 11 to that fraction. Or you could go about distributing this 12 and then solving for x in like a two-step normal algebra equation. So let's go ahead and just do it the second way, just because I think that's what a lot of people would do first. So let's go ahead and distribute this 12, which is going to give us 12x minus 132. That 132 came from 12 times the 11. Then from there, we have that still equal to the negative 15. Now, since we are subtracting that 132, that means we're going to add the 132 to both sides. So if I have negative 15 plus 132, that's going to give me the 12x, which is going to come down, equal to 117. Then from here, we're going to divide both sides by 12. So we end up with 117 over 12. Now, if you go ahead and plug that into your calculator, it ends up giving you 9.75. And if you're using a TI-84, remember you can just hit math, enter, enter to get that as a fraction, reduced, and that's going to reduce to the fraction 39 over 4, which means our final answer here is E. Now, this is one of those situations for number 10 where, like, if you know all the rules, you could probably just do this in a matter of a few seconds in your head. But I want to explain what each of those rules are so that when this pops up, you know how to do them quickly in your head. So starting off, it gives us this angle right here, but it wants to know what the degree measure is of BCE. Now, first off, looking at these, remember the middle guy is like the point of your angle, all right? So that means we're starting at B, the point is at C, and then our E is the other mention here for the ray. So we're looking at BCE, so we're looking at this angle right here, which they do clearly mark. Now, let's start off. First rule. There are 180 degrees in a triangle, so I can do 180 minus 2 of my angles to find a third. In this case, they only give us 1, but they do bring up that this is an isosceles triangle by saying this tally mark and this tally mark mean that the two of these are equal or congruent. Well, there's a rule that says isosceles triangles will have the same angle down here at the bottom. So that means we have another 25 right here. Now we can use that 180 rule to do 180 minus 25 to give me 130. Now we also know that a line is 180 degrees, so if this is 130, then this guy right here should be 50. And again, by our little isosceles triangle thing, if this is 50, then this one over here must also be 50. And again, by the 180 rule, 180 minus that 50 is going to tell me that this angle right here is 130. So our final answer is J. Now, to save time, me personally, I would probably just plug this number into this equation right here, into the calculator, and then just get my answer. Just because, yes, you could probably do this in your head, and I'm actually going to show you guys how to do it, plugging it in. But you could just save some time by putting it in the calculator and going from there. Now, if you were actually trying to solve it out, f of negative 2 is called function notation, and that just means that you're taking this negative 2 and you're plugging it in for whatever the letter is here. So in this case, in for the x. So if we go ahead and do that, negative 2, the first thing you would do is square it right here. So we have 9 times 4, because negative 2 squared is a positive 4. So 9 times 4 is going to give me 36. We then have 5 times negative 2, which is going to give us negative 10. Don't forget that negative. And then we still have that minus 8. So if I do 36 minus 10, that's going to give me 26. Then minus another 8 is going to give me 18. So our final answer here is C. So number 12 here is looking for a least common multiple of 30, 20, and 70. Now, when we're looking at these, it's really equivalent to say that we're looking for the least common multiple of 3, 2, and 7, since all of these are divisible by 10 evenly. So we can just go ahead and jump into looking at that, but we need to remember that we're doing that at the end here. So what's the smallest number that all three of these will divide evenly? Well, because 7's the biggest, we can just go ahead and start checking multiple of 7's to see what works here. So if I do 7 times 2, that's going to give me 14. And 14 is not divisible by 3, so that's out. 7 times the next one up, it's going to be 21, not divisible by 2. Then we got 28 after that. And 28 is not going to work either because that's not divisible by 3. And we keep going through this method. Now, what we will end up seeing is that the first one that will be all of them is 7 times 6, which is 42. But we have to remember that we are doing a multiple of 10 for each of these, so don't leave it as 42. You actually need to look at it as 420 to make sure we fall back into this 30, 20, 70 mark. So then when we're looking here, 420, that looks like our final answer would be J. So I'd argue this is actually probably a pretty easy question. It says here, while doing a problem on his calculator, Tom meant to divide a number by 2, but instead he accidentally multiplied the number by 2. Which of the following calculations could Tom then do to the result on the calculator screen to obtain the result he originally wanted? Subtract the original number, multiply by 2, multiply by 4, divide by 2, divide by 4. So in this case, he essentially originally wanted x divided by 2. Instead, he multiplied by 2, so he ended up with 2 times whatever that number was. So we want to go from here to here. Obviously, multiplying by another number is not going to help the situation. We're just going to multiply even further down the hole, and that would be a bad idea. So then we got to look, what is the opposite of multiplying? The opposite of multiplying is dividing. So in this case, we want to divide. Now, if we just divide by 2, it's going to cancel the original 2 out, so we don't want that either. We want a 2 left over on the bottom. So if we divide by 4, then that means the 2 will cancel out with 2 of that 4. So if we think of it as 2 times 2, then the 2's would cancel, and I'd be left with x over 2, which is what we originally wanted. So our answer here is E, divide by 4. So number 14 is not too hard. It's just a bunch of small, easy steps to get the whole thing. So the first things first, let's see what it says here. The 8-sided figure below is divided into 5 congruent squares. The total area of the 5 squares is 125 square inches. What's the perimeter in inches of the figure? So we're trying to find perimeter is how long the entire outside of this thing is. But it doesn't give us any of these lengths. Instead, it gives us the entire area. But it does say that each one of these are even. They're perfect squares. And the total is 125. Well, since there's 5 of them, we can just divide that 125 by 5 to see how much the area is for each one. Well, 125 divided by 5 is going to give us 25. So each one of these little squares has an area of 25. Well, now that we know that, because they're a perfect square, we know that area is found by length times width, so side by side. So what times itself will give me 25? Well, that's the same thing as taking the square root. Square root of 25 is 5, so 5 times 5, which means now we know every one of these little square side lengths is 5 inches long. Now we can go about finding the entire perimeter. So we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. So our final perimeter should be 60 inches long, which is answer G. So for number 15, it says that Hi has $100 available to buy USB drives. And each one of these USB drives is going to cost $8. But he'll have to pay a sales tax of 7% on each one. And it wants to know what's the maximum number he could buy with this $100. There's lots of different ways you could tackle this. The easiest is to probably think of it as like, okay, how much total is each one individually? And then see how many of those he could buy with $100. Now, with a sales tax of 7%, I can do 8 times 7 to get 56 to tell me that a price of each drive is actually going to be about $8.56. All right, now, I can go ahead in here and say if that's the case, I can probably just guess and check with some of these answers to see what's the highest number that would work. If I go through and do 15 times that 856, that's going to end up giving me $128.40. That's way high. Let's go ahead and go down to, I don't know, let's try 13. So if I do 13 times that same 856, that's going to end up giving me 111.28, which is still too high. So let's try the 12. So 12 times $8.56 is going to end up giving me $102.72. So that's still too high. Let's try all the way down at the bottom. 11 times that $8.56 is going to give me $94.16. So it turns out that 11 is the only answer here that works.
Well, guys, that's all the practice we're going to do today. So thanks for joining me. And remember, if you want to see more content like this, go ahead and click one of the videos over here, and we'll go ahead and hook you up.